Hey guys, Professor M. We're back for another video, and in this video we're going to be talking about ionic formations. Well, ionic formations is pretty much just an element becoming the nearest noble gas. And as I've talked in my previous videos, noble gases such as helium, let's do a bright color just so you guys can see better. So we have helium, we have argon, we have neon, for example, and all these are noble gases, and all these have stable electron shells. And when you have stable electron shells, that just means the maximum number of electrons in each shells is achieved, and no electron is without a second pair of electrons. So, for example, if we take neon, for example, well, the Lewis dot structure for neon will look like this. And what we're seeing is that from these all electrons being paired is that neon does not need to gain or lose any electrons to become stable. It is already stable. And without even doing this, we could tell just because that neon is at 10. And if you look at 10, we see that 2 electrons are in the first stage, and we have 8 electrons in the second stage, representing that neon does not have a charge, as a charge for neon would simply be 0. And this charge of 0 would apply on every single noble gas, because it shows that any noble gas does not need to gain or lose electrons. And that's the point of ions. It's showing how many electrons need to be gained or lost in order for it to become stable. So, if we look at another element which is not stable or a noble gas, we look at something like nitrogen, for example. Well, we have nitrogen. The element is 7, and we have a -3 ionic charge. And what we're going to basically see is that we have 7 protons. So let's write that down firstly. That's stage 1, guys. Always identify how many protons are inside the element, because that's going to give you a good understanding of how many electrons are needed if you don't have this ionic charge. If you're already given the ionic charge, then it's quite simple to figure out the electronic configuration. You just have to figure out the shell numbers. So for nitrogen, it would simply just be 2 electrons and 5 electrons. What we're seeing from nitrogen's 2 electrons and 5 electrons is that this 5 electrons is missing 3 electrons, because the maximum number of electrons in shell 2 is 8. And it should be achieving 8, but it's achieving 5, so that means it needs to gain 3 electrons, so that 3 of its electrons can be paired with another electron to become stable. So if we do the current Lewis dot structure, what it would currently look like, guys, is that we firstly have this, and then we have 3 loner electrons. The electrons currently don't have a friend, and what we're going to do with this ionic charge is that we're going to add 1 here, we're going to add 1 here, and then we're going to add 1 right here. And what this is going to do is that it's going to make nitrogen, now the cool kid in school, it's going to make nitrogen into the nearest noble gas, which is neon. So let's do this ionic formation. So if we move over, let's write down firstly the brackets. This brackets is representing that an ionic formation is taking place. So if we want to make nitrogen the cool kid in school, the first step is always to add the brackets. So if we do this, the first step is that, like before, we need to write down the number of protons. Well, we have 7 protons. We have nitrogen, so that's step 1 completed. Well, step 2 is figuring out the perfect electron configuration. Well, the electron configuration it will be 2 electrons, and it would then be 8 electrons. And what we're going to do is that we're going to add -3 here. What this -3 is going to do is that it's representing that 3 electrons have been added to nitrogen in order for it to become stable. So now that we know that these 3 electrons have been adding and nitrogen is now the cool kid in school, let's do it with a different example. Let's do it with a metal, which has a positive charge rather than a negative one. So if we move over and we take something like sodium, for example. Well, sodium has a positive 1 charge, and the atomic number is 11. So if we're to do the normal configuration, what it would currently look like is that we have 2, 8, 1. And what we're seeing is that to become stable, and to become the near stable gas, we can either become argon, and for argon we would need to gain 7 electrons. Or what we could do is that we could become neon and become the other cool kid in school, and we could make sodium just lose 1 electron. So now we're going to get rid of this idea. We're going to simply just have 2 and 8. And 2 and 8 isn't going to be enough for sodium to become the new cool kid. So if we do the same electronic configuration as we did with nitrogen, well, the first step is going to do, again, to write those big brackets. And these big brackets are just simply just giving you room. And it's also showing that an ionic formation is taking place. So if we write down sodium, and let's write down the number of protons. Well, we have 11 protons. Let's write down this big circle. And when you're doing this big circle, you're just showing that, sodium is now having 11 protons. So let's now do the electronic configuration. Well, we have 2 electrons, and now we have 8 electrons. So let's just write this. And we're going to add the plus 1. And you don't need to add the plus 1. You can simply just add plus, and that's going to represent 1. And what we're currently showing with this ionic formation is that let's get a different color, is that we simply had, originally, we had 1 extra electron, and what this positive is doing is that we got rid of electrons, so that's making us more happy. So then once sodium got rid of the negative 1 electron inside its life, it became more positive, making it more stable. And the stability has now given it 2 electrons and 8 electrons, which is making it into neon. So, I hope you guys have understood ionic formations, how ionic formations work, and what the key steps are when you're writing the ionic formations. What I want you guys to keep in mind when you're writing these is that simply just think of how many, firstly, electrons you have in the first place. What's the ionic charge? If you guys are still new to writing these ionic charges, always do this process. It's going to be much simpler for you. If you can find out the original electronic configuration, adding or minusing a couple electrons is not going to be that difficult. So I've hoped you guys have enjoyed this video, and more Professor out.